Hello. In the previous lesson, 9.2, we learned about similar polygons. In this lesson, we're learning about similar triangles. In the previous lesson, we learned that two things had to be true. All the corresponding angles of the two shapes had to be congruent, and all the corresponding sides of the two shapes had to be proportional. Conveniently, with triangles, there are shortcuts. The first shortcut is postulate 9.1, angle-angle similarity, which we abbreviate AAA for angle-angle, and a little tilde mark for similarity. If two angles of one triangle are congruent to the corresponding two angles of another triangle, then the triangles are similar. So given angle P is congruent to angle U, and angle T is congruent to angle R, we can say these two triangles are similar by angle-angle similarity. The reason why we don't need it to be angle-angle-angle similarity is because we know automatically that these two angles must be congruent based on the fact that all the angles add to 180. And if these two are congruent and these two are congruent, then by default these angles must be congruent. But again, we only call it angle-angle similarity. Another shortcut to determine if triangles are congruent is side-side-side similarity, which we abbreviate SSS with a little similarity mark. Be careful here. Some students get confused that the sides have to be congruent, and if the sides were congruent, you'd have congruent triangles, which are automatically similar. But not all similar triangles are congruent. If the measures of the corresponding sides of the two triangles are proportional, not congruent, but proportional, then the triangles are similar. Draw a diagram to illustrate this theorem. Let's say we have this triangle with sides 5, 12, and 13. Let's say we have this triangle with sides 10, 24, and 26. We can see these are going to be similar triangles, as if we match corresponding sides, 5 over 10, 12 over 24, 13 over 26. We see that we get the same scale factor of 1/2, and that all the sides are proportional. Now if this side had been 25 instead, we're not going to get exactly 1/2 here, so they would not be similar triangles. But because the corresponding sides of these triangles are proportional with the scale factor, we say the triangles are similar. Theorem 6.2 is our last shortcut to show triangles are similar. We have side, angle, side, which we abbreviate SAS. Similarity. If the measures of two sides of a triangle are proportional to the measures of the two corresponding sides of another triangle, and the included angles are congruent, then the triangles are similar. It's important that the angle is the included angle. So let me draw you a diagram. Let's say we have this triangle with sides 10, 8. And the included angle is the angle that touches both sides with those measurements. So this is the included angle. This angle is not the included angle because we don't know this side length. This angle is not the included angle because we don't know this side length. This angle is the included angle because we know both side lengths that form the angle. And let's say we have this triangle, included angle, and let's say this is 5 and this is 4. So notice we have 10 over 5. That's the same as 8 over 4. They both equal 2, so the sides are proportional. And we have the included angle. So that's side, angle, side. Similarity. Important note here. These shortcuts only work for triangles. They do not work for any other polygons. I'd also like to point out, maybe I'll write it up here, we have these shortcuts we just discussed. The postulates and theorems we used for congruence, similar triangles. We had several. Just wanted to point out how similar these are. We have side-side-side similarity, and we use side-side-side to prove triangles congruent. We have side-angle-side similarity, and we use that to prove side-angle-side congruence. Although we don't have AAS similarity, notice that our angle-angle similarity kind of matches to the angle-angle-side and angle-side-angle. But we don't really need that extra side in there. Determine whether each pair of triangles is similar. Justify your answer. Note you must mention something about corresponding angles in the corresponding sides if you claim the triangles are similar. So in this first example, we aren't told anything about the angles, so we're not able to use angle-angle similarity. And again, we're not told anything about the included angle, so we can't use side-angle-side similarity. So we're left with, are they similar by side-side-side similarity? So we'll match the smallest side, 8 over 6. That should equal 12 over 9, and that should equal 12 over 9. If all these are equal, then we would say the triangles are similar. If I reduce, this is 4/3. Divide by 3, 4/3, 4/3. So we would say triangle ABC is similar to PQR by side-side-side similarity. So you need to show your work that the sides are proportional. You need to include the similarity statement, how the two triangles are congruent, and you need to justify your answer based on one of the theorems or postulates. In this example, you can see pretty quickly that you have angle-angle similarity. We did not include how to name this triangle, but just to give you practice with stating similarity statements, we would say triangle ABC is similar to triangle EFG. making sure that angle A corresponds with angle E, and angle B corresponds with angle F. I'd encourage you to pause the video now and see if you can determine if these two triangles are similar. Sometimes it's helpful to reorient the triangles so they look similar. So I'm going to reorient the second one. Put it up here. The 18 is going to match with the smaller of the two. 24 is going to be over there. That's a little easier to see now which sides are corresponding sides, like that. So we need to know, is 18 over 20, is that equal to 24 over 36? Are the sides proportional? Well, I'm not too hopeful since 24 is so far from 36, but we could reduce. That would be 9/10. Does that equal 2/3? They're not equal, so we would say the sides are not proportional. So the triangles are not similar. So this is the case where the two triangles are not similar, whereas the first two were similar. On the next page, we're given RS, this side, is parallel, that symbol is parallel, to this side UT. We're told that RS measures 4, RQ measures x plus 3, QT is 2x plus 10, UT is 10. In order to figure out this question, we would need to show that the triangles are similar. Otherwise, there's no way to answer it. So I'd encourage you to pause the video and chat with your neighbor. Out of the three options, angle-angle similarity, side-angle-side similarity, or side-side-side similarity, which postulator theorem can you use to show that the triangles are congruent? So pause the video and chat with your neighbor. We can't use side-side-side similarity since we don't know these sides, and really we don't know these sides either. Likewise, we can't use side-angle-side similarity since we don't know these sides, and again we don't know these sides. We only know one pair of corresponding sides. So there must be a way to show the triangles are similar by angle-angle similarity. These vertical angles are congruent, and these alternate interior angles are congruent. And frankly also these alternate interior angles are congruent. So we could state that SQR is similar to UQT. And because they're similar, we can write a proportional statement. So we can write 10 over 4, since UT and SR are corresponding sides. (10 over 4). That would equal 2x plus 10 over x plus 3. Notice I started with the 10 and went to the 4. So I put the 10 in the numerator. I have to be consistent and put the 2x plus 10 in the numerator, with x plus 3 in the denominator. And as you learned a few days ago, when you have a proportion like this, which is two fractions equaling each other, we multiply these and we multiply these. So we get 10 times x plus 3 equals 4. 2x plus 10. 10x plus 30 equals 8x plus 40. Subtract 8x from both sides. Subtract 30 from both sides. We get x is 5. However, that's not our final answer, is it? We're actually asked to find the length of RQ and QT. So plugging in 5 for x, 2 times 5 plus 10 is 20. And 5 plus 3 is 8. So RQ is 8. QT is 20. And that's our final answer. Are the following triangles similar? Here we're given side lengths, and we're given angle measures. So you should label the diagram with the given information, and then determine which of these postulates or theorems you can use to determine if the triangles are similar. I'll let you figure that out with your neighbor. And then you can begin the homework. Thanks for watching this video. I hope to see you soon.